In this video, we're going to discuss using your properties of exponents with rational exponents. All properties used with integer exponents apply to rational exponents in the same way. Let's take a look at our first rule we had when multiplying same bases. Our rule was to simply add the exponents, so a squared times a cubed equals a to the 2 plus 3, or e equals 5. That applies the same way with fractions. A to the 1/3 times a to the 2/3. We simply add the exponents, 1/3 plus 2/3, which in this case equals 3/3. But with rational, we do have to reduce our fraction, so this becomes 1, or just a. Now, if these had not had the same denominator, then you would have had to find common denominators like you normally add fractions, and complete it then. Here's another power rule, x to the 4th taken to the 3rd power. Here our job was to multiply the two exponents together, so 4 times 3 gave us x to the 12th. It is applied the same way with rational exponents. 1/3, x to the 1/3 taken to the 2/3 power. We simply multiply 1/3 times 2/3, which is 2/9, and so x to the 2/9 is the answer. Let's look at one more rule, and this is our division rule, where we have a to the 5th divided by a cubed. So we subtracted the exponents. A to the 5 minus 3 equals a squared. We do this the same way with fractions. We have a to the 4/5 divided by a to the 2/5. A to the 4/5 minus 2/5, well, 4 minus 2 is 2, so we have a to the 2/5. Now here's a sample problem where we're going to simplify using our properties of exponents. And there's actually two approaches to this that you might do. I'm going to start by noticing in each parentheses I have a variable that I could reduce before multiplying across. So for example, I can see up here that I have a to the 3/4 divided by a to the 1/2. So maybe I would like to just go ahead and work with those first. So this would be obviously a to the 3/4, but I need to change the bottom a from 1/2. It needs to be as a common denominator. And so that means 1/2 is equal to 2/4. So this will be a to the 2/4. So now this 3/4 minus 2/4. My a's have now simplified to a to the 1/4. We still have our b to the 2/3, but now the first one has been simplified to this. Now let's take the second one. I see that I have two b's. I have a b on the top, b on the bottom, so I could subtract those exponents. They don't have the same denominator, so I will have to come up with a common denominator between 4 and 6. And the lowest common denominator I'm going to use is 12. So for my b's here, I would take the first one, b to the 3/4, and exchange it with 1 who's equivalent to the denominator of 12. Well, 4 times 3 is 12, so I'm going to multiply the top by 3, so the numerator becomes 9, 3 times 3. And on the bottom, we had b to the 5/6, so again, same denominator of 12. 6 times 2 is 12, so I need to multiply the numerator by 2, by 2. And now I get b to the 9/12 minus b to the 10/12. So I'm going to bring down the a to the 1/4 here. And now my b has simplified to 9 minus 10, or negative 1/12. Now I could put that in the denominator now because that's what a fraction or a negative exponent means, but I'm going to leave it here for now and see what happens with my arithmetic. Now I'm going to go across. So I'm now going to take the same base as a to the 1/4 times a to the 1/4. So I'm just going to rearrange them so you can see the same bases. And over here I'm going to take b to the 2/3 times b to the negative 1/12. Now the a is relatively simple because it is 1/4 plus 1/4, which is a to the 2/4, but we need to reduce that, so this becomes a to the 1/2. Now over here though, again, we don't have the same denominator, but 3 goes into 12, so we'll just use the denominator that way. So let's change 2/3 to a fraction with a denominator of 12. 3 times 4 is 12, so I'm going to multiply the numerator by 4, which gives me 8. So I have 8/12 times b to the negative 1/12, and 8/12 plus negative 1/12 is b to the positive 7/12. So my answer is a to the 1/2 power times b to the 7/12 power. Now to demonstrate the second way I could do this is I'm going to now do it as if I was multiplying straight across first with the numerators and then dealt with the denominators last. So to do that, I'm going to go over to the right here to save some space. I'm just going to draw a line so you can see where I'm working. Alright, now over to the right, let's start with a to the 3/4 times a to the 1/4. Now again, multiplication can be put in any order. It's called commutative property. So I'm going to write next to each other a to the 3/4 times a to the 1/4, just so you can see the same bases easier. And that leaves me b to the 2/3 times b to the 3/4. And all of this is still over a to the 1/2 times b to the 5/6. Now let's take the numerator. So a to the 3/4 times a to the 1/4, and I can see that 3/4 plus 1/4 is going to give me a to the 4/4, which I'll be reducing to 1 here in a minute. Now the b's don't have the same denominator, so 2/3 and 3/4, I'll take the LCD of 12. So 2/3 with a denominator of 12. 3 times 4 is 12, so I'm going to multiply the numerator also by 4, which gives me 8. And b to the 3/4, denominator of 12, 4 times 3 is 12, so I'm going to multiply the numerator by 3 and get 9. So now we have a, this is all still from the numerator here. I have b, 8 plus 9 is 17/12, and all of this simplified numerator is now still divided by a to the 1/2, b to the 5/6. Now let's go down a little bit lower and let's go ahead and do the division. So a divided by a to the 1/2, well, I'm going to need a fraction to subtract from. So I'm going to take the 1 that, again, we assume is here if we don't see it. I'm going to make that 1 equivalent to a denominator of 2. So a to the 2/2 divided by a to the 1/2. Now we have up here b to the 17/12. I need a common denominator, so my b on the bottom will make the 6 into a 12 by multiplying it by 2, which means multiply the numerator by 2, 10/12. And now we do our subtraction. 2 halves minus 1/2 will leave me a to the 1/2, and 17 minus 10 gives me b to the 7/12. And you can see now that I've gotten the same answer just by going different routes that I wanted to. So you can see sometimes there'll be multiple ways to approach it. Now I'm going to have you try. You're going to try this one. Pause the video. Once you've attempted this problem, then restart the video and watch my solution to see how you did. For the benefit of those who did it maybe different ways, I will again complete this one in 2 different ways. So I'm going to start on the left. I'm going to take a to the 6/7 and divide it by a to the 1/2 first. So I'm going to need a common denominator between 7 and 2, and that will be 14. So we will convert the numerator from 6/7 to 12/14. 7 times 2 is 14, therefore 6 times 2 has to be the numerator of 12. And on the bottom I have a to the 1/2. If I make the denominator 14, that's 2 times 7, and 7 times the numerator 1 is 7/14. A little bit hard to see that that's a 7. So 12/14 minus 7/14 gives me a to the 5/14. And the b to the 1/3 I haven't dealt with yet, so it's still in the problem. Over here I have the b's. So I'm going to take the b to the 1/2 divided by b to the 5/6. Again, I need common denominator. So in this case, 2 and 6, the common denominator is 6. So 1/2, if I take 2 times 3 to get the denominator of 6, I take the numerator times 3, so 3 times 1 and 3/6. And b to the 5/6 is on the bottom. And 3/6 minus 5/6 is going to be b to the negative 2/6, or b to the negative 1/3. So let's bring down my a to the 1/7. Now we'll multiply straight across with a to the 5/14. And we'll bring down our b to the 1/3. So now going across 5/14 and 1/7, again I do need my common denominator, so we'll start with a to the 5/14. We'll convert 1/7 to a common denominator of 14. So that's going to give us 2/14. And our b's are going to be b to the 1/3 and times b to the negative 1/3. So in our first case, we have 5/14 plus 2/14. So our final answer with a is going to be 7/14. Which is going to come out to be 1/2. So we have a to the 1/2. And our b, 1/3 plus negative 1/3, is b to the 0. And b to the 0 is 1. So final answer, simply a to the 1/2 power. Now for those who did it the other direction, I'm going to go ahead and do that one. So now I'm going to focus on doing across first. So we'll take my a to the 6/7 times a to the 1/7, b to the 1/3, multiplying across to my b to the 1/2. A to the 6/7 plus 1/7, that gives me a to the 7/7. Now this one over here, 1/3 and 1/2, need a common denominator. So we'll convert to a denominator of 6. So 1/3 becomes 2/6. 1/2 becomes 3/6. So now all of this is still over our denominators. I haven't forgotten about these yet. Okay, they're still here. So my top one, a, now becomes a to the first power. And my b, 2 plus 3, or 5/6. And this is over a to the 1/2, b to the 5/6. Okay. So again, I need common denominators for the a. So this is going to be a on top to the 2/2 divided by a to the 1/2. And these already are the same, b to the 5/6 divided by b to the 5/6. So I end up with 2/2 minus 1/2, or a to the 1/2. And even if I did do 5/6 minus 5/6 to get b to the 0, which becomes 1, so my final answer is still a to the 1/2. You may have simply noticed that over here, anytime you have a same base to a same exponent, When you divide by itself, you get 1. So this could have just been reduced to 1 in that respect. So no matter which way you did it, you should have gotten a to the 1/2.